Okay, so for us to answer this question, it would be really helpful for us to define like what an integer is. So can anybody tell me like something about an integer? Renee, go ahead. Is that your hand?
An integer is a number that is not a fraction or decimal.
Okay, a number that is not a fraction or decimal. That's a pretty good description. So what does it include? It includes whole numbers, negative whole numbers, and then there's one other piece. That's neither of those things. Zero, yeah. So integers include positive whole numbers, negative whole numbers, and zero. So if we look at this list, 10, integer? Yes. Negative 2.2. No, because that decimal makes it not an integer. It's a different type of number, which we're going to talk about, but not an integer. Negative 14. Is that a 14? Yeah. Yes, integer, negative whole number. Zero, we just talked about, integer. 100,000.2, no, decimal. And then 148 would be an integer. There are other ways that we can classify numbers. Does anybody know another type of number? So integer is one type, yeah. Rational numbers, we're gonna talk about those today, yes. Irrational numbers, which is the opposite of rational. There's two other categories. Anybody know the other two? Natural numbers, yeah. And then whole numbers is, oh, is that what you're gonna say? Sorry. Whole numbers is the other one. So if you wanna go to your notebook, we're gonna talk about all of those categories and what specifically they are made up of. And for those of you that the drawing tool is like a little frustrating, we're gonna just be listing a lot of stuff, so typing might be like the better option today, but that's totally up to you, okay? So if you look at this visual, what do you notice? Yeah, Zion.
The box inside with the natural numbers is like smaller than the other.
Yeah, you can see that natural numbers is like inside all of the squares or squares, I shouldn't say square, they're rectangles. Natural numbers is that smallest rectangle, and it's inside of whole numbers, which is inside of integers, which is inside of rational, and then irrational is over there by himself because he's just not like all of the other ones. And there's a reason. Because natural is the most specific type of number we can have. When I think of natural numbers, I think of like when you start counting, what number do you start with? One, then 4, then 5, to an infinite number of numbers. But the key thing here is when we talk about natural numbers, we are starting with 1, and we are only including those whole numbers. So if you want to just list like 1, 2, 3, and then I'm going to put like ... because it goes on forever. Does anybody know what those ... dots are called? They have a name. Ellipses, yeah, they're called ellipses. They mean like etc. or like keep on going forever. So the reason why natural is inside all those other boxes is because all those numbers are also whole numbers. They're also integers. They're also rational. So we could call the number 1 natural, whole, integer, rational, and all of them are called real numbers. Now, oh, sorry, go ahead. Did you have a question? That's a bummer. I thought I fixed it. You just ruined my day. I'm just kidding. Hold on. Fixing. Okay, do me a favor, refresh the page for me. And then let me know. You should be able to see my 1, 2, and 3 inside your new page, hopefully, in theory. Okay, so whole numbers is almost the exact same thing as natural, except for one number, not the number 1, except for one number. What is it, Madison? 0, yeah, 0. So whole numbers include 0, 1, 2, 3, and so on. Graham, that work? Sweet. Okay, and then integers we kind of already talked about. So integers includes not just 0, 1, 2, and 3, but the opposite direction, -1, -2, -3, and so on. So I'm going to do my little ellipses. And then I want to include -2, -1, 0, 1, 2, and then my little ellipses that go in the opposite direction. And then some of you mentioned rational numbers. What is a rational number? Yeah.
Numbers like decimals.
Numbers like decimals, specific kind of decimals. And then there's another key thing for a rational number, fractions, right? So we could include fractions, we can include decimals, but those decimals have to either be terminating. What's terminating? Ending, right? Stop. So like 2.7. Notice how nothing is coming after the 7. That's considered a terminating decimal. Or a repeating decimal. And how do we know if the decimal's repeating? What does it have? Yeah. Right, it has that bar over it. So if we did 2.3 repeating, that 3 has that line that tells me repeating over. Fractions are included in rational numbers, so like 1/2. Mixed numbers are also included, so 4 and 1/5. All of those are underneath the umbrella of rational. Okay, what about irrational? There's one like extremely famous irrational number. Go ahead, Kylie, what is it? Just trying to find her unmute button, I think. She's trying to unmute, it's fine. Here, I can unmute you. Go for it. Oh.
What did you ask? I was in the notes.
Oh, no, sorry. I was saying, you're good. I'm asking what's the most famous irrational number? Do you know what it is?
No.
No? Okay. Here, Renee, I'll unmute you. Go for it.
Pi.
Yeah, pi. Pi is irrational. So pi is irrational because, that's the key thing here, because it does not repeat and it does not end. Pi goes on forever and never repeats. It's 3.141592, blah. There's more. How does it never repeat? What do you mean? Like, so it doesn't go like, you know how like 1/3 as a decimal is like 0.333333, that same number is the same number. Pi, the numbers change the entire time that it keeps going on and on forever. There are other types of irrational numbers that may not be as familiar for you. The square root of 11 is considered irrational. If you have a calculator, I want you to, and you can use the one on the computer too if that's better for you. I want you to take the square root of 11 and look at what happens when you do that. Let me see. Do I have a calculator? I think I do. There's a calculator on an iPad, right?
Yes.
I have to go download it. Dang it. Say it louder for me, Thorn.
Isn't that like 3.31664790355?
Yeah, blah, 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 blah. Yeah, so it's the same thing as pi. Pi doesn't repeat, pi doesn't terminate. But neither do, I call them non-perfect square roots. So what if I were to ask about the square root of 16?
Yeah, how do you do square root
On those calculators, the like white silvery ones, hit the second or the shift, but hold on, I take that back. Type the number. So if we were to do a square root of 11, type 11 and then hit shift, which is in the top left. And then second or the third button on the top row that says x squared, click that. That takes the square root. Okay. Yes. I'm not sure. If you look at insert, there may be a math option there, and that one might have square root symbol. Let me know if it does. What about the square root of 16? Yeah, Kingsley. 4. So would 4 be considered irrational? No, 4 would be all the way over here. Oh, whoa. What just happened? 4 would be all the way over here. So I would actually put the square root of 16 under natural numbers. What about the square root of 36? So like what number times itself gives you 36? 6. So that would also be under natural numbers. Another irrational square root would be like the square root of 19. I can't think of a number times itself that equals 19. It's something like 4.4 something. You can check me on that. I'm pretty sure that's what it is. Say it louder.
4.35.
Yeah. Yeah, but it's not a whole pretty perfect integer number, right? It's an ugly decimal that doesn't repeat and doesn't terminate. So what would be another irrational number? Square root of, what's your favorite number? 7. Great question, Renee. So basically every prime number square root is irrational. Yes, that is true. But it doesn't necessarily have to be prime. So square root of 10 is actually still irrational because I can't think of a whole number times itself that gives you 10. So it's not necessarily that it's prime. It's just because you can't take a perfect square. The square root of 10 is like 3.1 or 3.2, something like that. Okay. So these categories actually have special letters that go with them. So if you want to scroll right underneath here, we're going to assign them letters. And I'm not just making these letters up. These are like the math official letters for each of these categories. So natural numbers, what letter would make sense to represent natural numbers? N, yes, N. So N is going to represent our natural numbers. And I'm going to list a few of those. So remember, those are like, oh, I'm just messed up, not 0. We're starting with 1, 2, 3, 4, and then my little ellipses for my etc. Yes. You can't move. Let me just see if I can fix that. This is what I do. How do you usually get to your notebook from here? You're welcome. Okay, so our next biggest category is whole. What letter do you think represents whole? W, yeah, we're making sense so far. So whole numbers, remember, are almost the same as natural, except it starts with 0. Okay, what about integer? What letter? Yeah, it's not I, unfortunately. It's Z. Yeah, so last class or first period, they were like, well, why the heck is it Z, Miss Simpkins? So I looked it up. It's a German word. And let me remember how to say it. Integers, Z. Let me remember. I mean, it says Wikipedia told me this. You know, Wikipedia can be wrong, but I'm just going to trust Wikipedia. I can't find it right now. I don't want to spend too much time on it. But if you want to Google it later, Wikipedia told me it came from a German word. It was like Z and something else. So whenever, and it means number in German. So they use that Z because what could I be used for? And we're going to use it in a second. What could I be used for? Irrational. So we can't use I twice, right? We can only use it in one of those places. So we're going to use Z for integers. So remember, those are my negative and positive whole numbers. Okay, what letter for rational? Probably, yeah, it's not R. Because R is for real numbers, okay? Q. This one actually makes sense. Rational numbers are fractions. Fractions are division. What's the answer to a division problem? A quotient, yeah, it starts with a Q. Oops. Oops, I'm just messing up all over the place here. Hold on one second. So our rational numbers, remember, were fractions, like 1/2, or four mixed numbers like 4 and 1/4, or they were our terminating or repeating decimals. So 2.7 would be our terminating decimal, and 4.6 repeating is just my example of our repeating decimal. And the last category is irrational. So that would be an I. And irrationals are like pi, and then any square root that's not perfect. So I'm going to do square root of 13, square root of 27, square root of 50. All of those would be considered irrational. So here's what I would like you to do. On the right-hand side, you should see 6 numbers. They're written vertically. I want you to tell me all of the categories that that number can belong in. So what I would do is I might start with the most specific you can think of and name the ones after that. And you can just use the letter if you would like to. So if you're calling it an integer, you can just use Z if you want to do that. Or if you want to write out the whole word, I'm fine with that. Either is good with me. Okay, so let's talk about these 6 numbers and where they should go. So let's start with 37. So what would be the most specific category that we could place 37 into? Yeah, natural, I agree. So natural numbers, and because it's natural, that means it's also whole, it's also an integer, rational, and real. Whew. All of those. Negative 37, the most specific category we could get into would be integer, because it's a negative whole number. So that means it's also rational and real. 3 1/5. If I see that 1/5, I can't do anything. It's as simple as I can get it. So since it has a fraction, it's just a rational number, but remember all of the numbers we're dealing with are also real numbers. We good with those? Any questions, comments, concerns? Okay, let's look at the last 3. So it got a little bit more difficult on the last 3. So negative square root of 100. So first things first, can we simplify square root of 100? Yeah, what number times itself gives us 100? 10. But we need to make sure that we're bringing that negative over with it. So negative 10 is actually the number we're classifying, which would be integer, rational, and real. So anytime you see something like a division problem, which is what we're going to get to next, or a square root, see if you can simplify it first and then categorize whatever you are simplified to. So negative 8 over negative 2, we can simplify that. Negative 8 divided by negative 2 is 4. So 4 would be the number that we are actually seeing what category it goes into, and it is natural, whole, integer, rational, and real. And then the last one, we kind of talked about this one a little bit already. Square root of 11 is irrational, but it's still real. All the numbers that we're talking about are real. There are things that aren't real numbers. They're called imaginary numbers. They do exist. You will talk about them in like algebra 2 or pre-calc, somewhere up there in high school. You know, when you were like learning how to subtract and your teacher taught you like, you can't do 4 minus 6. It's not allowed. And then like 2 years later, your teacher's like, but you can, there's negative numbers. Remember when that happened to you? So like, that's kind of the same thing here. So everything we look at in my class are real numbers, but there are things that are called imaginary numbers, and it's something like this. The square root of negative 6. Yeah, try it. It probably will say error or something like that if you try and put it in your calculator, or it might say 0, I don't know. Because can you think of a number times itself that'll give you something negative? Because think about that. A positive times a positive is going to give you positive. A negative times a negative is going to give you a positive. Yeah. So, yeah, it's interesting stuff, maybe for me, but maybe not for you. But there is a thing called an imaginary number. So we have about 4 or 5-ish minutes. Oh, I can't count. My clock on here says 3:45. The clock on here does not. So y'all can use the rest of class to work on homework 6.